All right, here we go. We are thinking about day 1 of Water's Role Explain Notes. We have 2 sections that we're looking at today, parts of an investigation and weathering, erosion, deposition. We've seen both of these a little bit already in our 2 explores, but now we are thinking through them in detail and kind of applying them a little bit further and starting to make some connections with our stream table lab. So kicking off here with parts of an investigation, that is of course learning target number 1. And like we talked about with our plant example, it's best to go through one thing at a time, right? So as we think about these variables or things that we can change or manipulate or measure, it's really important to focus on what that lab question is asking and only try to change the one thing that would have that impact, okay? All other variables must remain the same. Those are our controls. So let's look at an example here. As we think about setting up an experiment, first thing we want to do is, of course, create a hypothesis, right? Hypothesis is what we think is going to happen based on evidence, right? We've talked a lot about this, especially trimester 1, where it's not just a guess, but it's an idea based on what we already know. So everybody's background is a little bit different as we go into an experiment. If we have a certain idea about what's going to happen, this is where we apply it. So you're filling in your blanks right now on the left about hypothesis definitions. We know it's a proposed explanation based on evidence, or another way we could say that is based on our personal background, right? Our own ideas. And we write that out using this format, if, then, because, right? And that because connects back up to your background or your reason. Like we said, it is not a guess. So here's a simple hypothesis example. If, starting with that intro, this is what occurs. If I miss school, then what will the outcome be? Grades will go down. And why? What is our thought behind that, our background? Well, our because is we'll miss a lot of important information. I won't have the full understanding, and then I'll miss points somewhere, right? So that if, then, because pulls together what we think is going to happen and our why as of right now, right? We haven't done the experiment yet, so that will possibly change as the experiment progresses. So let's do a real practice for an if, then, because. We're going to do that over here on the right-hand side. So hop over there and make this happen. In a good experiment, you test one thing and control the rest. So here we have a graphic showing control variables for this particular experiment. Does red light affect plant growth? We already know light affects growth from our introductory experiment and our gizmo, but what about red light? Okay, how might that impact the growth if all the light bulbs were red versus yellow? And if you're following along and listening to me, just go ahead and put a little heart around your red light bulb so I can see that drawing on there and know that you were listening instead of just copying information down. But we're going to make an if, then, because. So if, I'll help you out with this first part. What is the setup, right? If a red light is used, instead of the normal yellow, right? If we switch it up and use red, then, well, what do we think the outcome is? And that's where you have to make your prediction. Are we going to see more growth or less growth, right? Make your prediction. More or less growth, what's it going to be? And then why? What's your thought? What's your reasoning? So I'll have you pause, take a second, and just give your background, your predict. Why do you think the red light would have that impact? And there's no wrong answer here because it's what you're thinking about right now. Okay, you've got your because written in there about what you think would happen for the red light. This is just a predict. We're not going to carry out this experiment right now, but we're just thinking through what would an ideal if then because hypothesis look like. So that's a great one. So let's circle back to these variable terms, right? Variables are things that we can change, control, or measure in our lab experiment. Controlled, these are the ones that I really like to think about when we make an experiment, is these are all the things that we want to keep the same or keep constant during the experiment. I don't want there to be any fluctuation with these because then my independent variable is not going to show the results related to that. Remember, independent variable is the one thing that we want to change in our experiment so we can reflect what we think the outcome is. So that previous example with the light, I'd only want the only difference between those two plants is to be the light. Everything else has to stay the same to decide, well, what kind of impact does that red light have? And finally, dependent variable. This is our results, right? Thinking about the data that we collected, what are we actually measuring? So in our last stream table lab, what we were looking at was the amount of erosion. And the only thing we were changing was that flow rate. We were really trying to think or keep a lot of those other details the same, like the channel, the sand, the slope, the water speed, like all those things we were trying to keep as consistent as we could so we could determine how that flow rate impacted our results or our dependent variable of erosion. So one more time, popping over to the right-hand side, thinking about an example once more using those different variables, independent, dependent, and control. So here's our example. We're thinking which tennis shoe would have the least wear on the sole of the shoe. Okay? The sole is this part right here, the bottom of the tennis shoe, this kind of like blue part right here. If we tested many different shoes, which one would have the least amount of wear? That's what we're looking for. So the one thing that we would want to change throughout the experiment was, of course, the shoes. And that might mean not only changing the shoes, but the reason we'd have different shoes is because what we're really looking at are the different soles, right? We want to look at shoes that have the different bottoms to figure out, well, which one is actually the best. How would I know which one ended up being the best? Well, that's my dependent variable. Remember, this is the data that I'm looking at. I would have to compare the soles at the end, right? I would have to compare the wear of the soles after whatever activity happened, right? Essentially, I'm looking at the quality of them after their use. So controls are what I need to think about to stay the same, right? Because I want to know only the different quality soles. So for example, one of the first things that always comes to mind here is the activity. What is the person doing in the shoes, right? I can't have person A wearing the Nikes run a 500-meter sprint, and then I can't have person 2 wearing the Adidas take a 2-minute casual walk, right? They have to be doing the same activity, whether that's a certain run and a distance, whether that is a game of tennis, basketball, right? Whatever it is has to be consistent. And it'd be helpful to have the consistency carry over to the same person, right? Again, I wouldn't want the Nikes to be a small, petite woman and the Adidas be a very large man, right? Again, those differences would have an impact on the shoe. I only want to know about the bottom of the shoe. So I'd want to keep the activity the same. I'd want the person to be the same. I definitely want the location, kind of thinking about the activity again, to be the same. Can't have them test on different surfaces. And if we're talking indoor versus outdoor, obviously the weather would have to be the same. Looking at this picture, I would want the socks to be the same, right? There's a lot of things that we would want to have control keeping the same. So the only outcome to our experiment was based on the bottom of the shoe. And that's really what we're trying to test here. So if you have any other ideas, you can certainly label them in. Again, if you are following along with me, listening, could you just put a box around the word 1 right here? So then I know that you're following along very well. Thank you so much. Moving on to part 2, weathering, erosion, deposition. These are all outcomes of water moving across the surface of the earth. So water's role, we're really thinking about, well, how does water have an impact on anything that it crosses over? Starting here with weathering, our key word last week when we looked at this was rocks being broken down, right? We're thinking about them breaking, being chipped away or becoming smaller over time. That is all happening with things on the Earth's surface. We can have wind, we can have different water, like rain, like rivers, like waves, all of those things changing the size of the rock. Even water freezing into ice can expand and make cracks bigger to break the rock further. So weathering is breaking it down into those smaller pieces, and that, of course, is our sediment that we are thinking about. Now, all that sediment, all those small pieces continue to get impacted by the water around them. One of the next ways is through erosion. Erosion is the picking up and moving of that weathered rock. Right? That rock is being picked up again by the force of water. It can also be wind, but water is definitely the driving force in a variety of different ways. And all of those different techniques are moving the sediment, picks it up and carries it for just about as long as it can. The final stage here then is deposition. This is where it gets deposited into its final resting place. Right? Gravity definitely helps out with deposition because materials are constantly being pulled down. Not only down slope, but down towards the bottom of these water type environments. This is a great example showing this flow of the river emptying out into the ocean. Just like our graphic in our Explorer, that speed changes a little bit and we see the sediment then start to fall downward like we do in this bottom image. So keyword here with deposition is that sediment is being placed or dropped off in a new location. Deposition happens typically when the slope gets changed and things start to flatten out like we'd see here at the end of a river, or water speed starts to slow down, maybe because the channel width changed as well. But those are two common things that allow deposition to happen more often: a flatter stream slope and a slower water speed. Both of those cause deposition, or the dropping off of sediments out of the water. So just one right-hand side here to finish up. How is deposition different from erosion? You just got your two definitions over here. Got a little visual again for each one. Go ahead, pause the video and give me a quick explanation. Here's what I know about deposition versus here's what I know about erosion. Can do a little T-chart. And finally, just a quick summary to wrap everything up. Got 3 definitions one more time: weathering, erosion, and deposition. We should be able then to match them up and record the definitions, or excuse me, the keywords here below to match the definitions that I've given you. So let's read them together. I'll kind of highlight some of those key parts. A pebble has been carried 50 miles downstream in the Mississippi River through rapids, around meanders, and over a waterfall. So we've got a pretty powerful river carrying some sediment. Example 1. As a river channel empties into the Puget Sound, the speed of the water slows down. Puget Sound is like a bay, and a lot of the sediment is carried, settles into a delta in the shallow water. So settles, what we mean is it's falling out and finding a resting place at the bottom of the shallow water. And finally, a glacier has melted and refrozen, making cracks in the rocks around it. So the large rock is now dozens of smaller pieces. So you should be able to match up which one's referring to weathering, which one's referring to erosion, and which one's referring to deposition. Great. Now that we are done with our notes, you got 2 things to complete today. 30 more seconds in this video. Make sure you pay attention very carefully. One is the homework check. So you're going to use the notes we just did to complete it. Like always, there's questions coming right from it and a screenshot. There is a timer, so make sure you are actively finishing it up before the timer closes, and it will not be available after the end of class bell. So as this video finishes up, you want to make sure you are done with it. Ooh, number 2 then is work on your study guide. And study guide obviously looks a little different this time around. There's nothing in here, right? It's blank. You still have the headers to match the notes, but you also still have this unit resource to help you out. So I just want to show you what that looked like. Looks like this. So I'm giving you kind of some reminders, some big ideas from each note section, and you get to decide how that looks. Okay, are you just going to copy word for word right from the notes? Are you making a diagram, a little T-chart? You're going to draw something? Are you going to just give a definition and example? Are you going to pull something from our stream table lab, from any of our explorers, right? You can add these details in. So like always, this is going to be available to you as you work that unit test. So the more details you have, the better off, or the better prepared you can be. Thanks for staying focused all the way through those notes. Make sure you have them while you're working the homework check. And as always, let me know how I can help.